Hello everybody, welcome into another lesson. So today we are going to continue with the trig identities and we are going to do what's called verifying trig identities. Now in a way these are a very small type of proof. They're much easier than geometry proofs though, so they're nothing like what we did in geometry with all those proofs. So you may be asked to verify the identity. So they give you that the cosine of x times the cosine of x times the secant of x equals 1. So how would you proceed to verify that? Well, start with your left-hand side and work to simplify it. So you'll have the cosine of x times the secant of x equals, now what is that secant of x? That's 1 over cosine, right? So that would equal the cosine of x times 1 over the cosine of x, which we know the cosines are going to cancel out, so that equals 1. Therefore, the cosine of x times the secant of x equals 1. So always have the therefore statement once you've proven that the left side equals the right. And that's really all there is to verifying these identities. It's really not that bad. Alright, what do we got next? We have the tangent of x times the cosecant of x times the cosine of x equal to 1. So we have to verify that the tangent of x times the cosecant of x times the cosine of x equals 1. So write out your left-hand side again. Tangent of x, cosecant of x, cosine of x equals, now let's simplify the left-hand side. So what is the tangent of x? Well, that's the sine of x divided by the cosine of x, right? Now, what is the cosecant of x? That's 1 over the sine of x. And then, of course, you just have times the cosine of x. And notice here, your cosines will cancel out, and so will your sines. So they equal 1. Therefore, the tangent of x, cosecant of x, cosine of x is equal to 1. All right. We have the cosine of pi over 2 minus x times the cotangent of x is equal to the cosine of x. So we have to verify that the cosine of pi over 2 minus x times the cotangent of x equals the cosine of x. Well, let's write out the left-hand side again. So the cosine of pi over 2 minus x times the cotangent of x equals, now let's simplify that left-hand side. So we have a cofunction identity here. So the cosine of pi over 2 minus x, that just turns into the sine of x times, now what's the cotangent of x? Well, that's your cosine of x divided by the sine of x. Well, the sine of x's will cancel out and you'll be left with the cosine of x. Therefore, the cosine of pi over 2 minus x times the cotangent of x equals the cosine of x. All right. We have 2 minus the secant squared of x equals 1 minus the tangent squared of x. So we have to verify that 2 minus the secant squared of x equals 1 minus the tangent squared of x. So go ahead, write out your left-hand side again. So you have 2 minus that secant squared of x equals, now, do we remember from the last lesson, what is the secant squared of x? That's 1 plus tangent squared, right? So this would equal 2 minus the quantity of 1 plus the tangent squared of x. Well, 2 minus 1 is going to be 1, then minus the tangent squared of x. So we've just verified it. So therefore, 2 minus the secant squared of x equals 1 minus the tangent squared of x. All right. So we have sine of x plus the cosine of x cotangent of x is equal to the cosecant of x. So we have to verify that the sine of x plus the cosine of x cotangent of x equals the cosecant of x. Okay, so let's verify that. So write out your left-hand side again. You'll have the sine of x plus the cosine of x cotangent of x. Now, we can definitely simplify cotangent, or we can express it differently. This would turn into the sine of x plus the cosine of x times the cosine of x all over the sine of x. Well, what you have now is the sine of x plus the cosine squared of x all over the sine of x. Well, we definitely need to get the same denominator for both of these terms. So if we do that, we'll end up getting sine squared of x plus cosine squared of x all over the sine of x. Now, what is sine squared of x plus cosine squared of x? That's just 1, right? So you would get 1 over the sine of x, which equals the cosecant of x. So therefore, the sine of x plus the cosine of x cotangent of x is equal to the cosecant of x. And we're halfway done with the lesson already. All right, let's see. So we have cosine squared of x plus sine squared of x all over 1 plus tangent squared of x equals the cosine squared of x. That looks hideous, doesn't it? It's really not as bad as you think. So cosine squared of x plus sine squared of x all over 1 plus tangent squared of x equals the cosine squared of x. We got to verify that. Dang pop-ups. Alright, so let's write our left-hand side out again. So cosine squared of x plus sine squared of x all over 1 plus tangent squared of x is equal to, now what's cosine squared of x plus sine squared of x? That's just 1, right? All over, what's 1 plus tangent squared of x? That's the secant squared of x. Now, just like secant's reciprocal of cosine, cosine's reciprocal of secant. So this would literally 1 over secant squared of x would give you cosine squared of x. And that's it. So therefore, cosine squared of x plus the sine squared of x all over 1 plus the tangent squared of x equals the cosine squared of x. So that one actually wasn't as bad as what it looked like when you first started. Alright, I have 4 more. So let's see. We have sine squared of negative x all over tangent squared of x is equal to the cosine squared of x. Alright. So we have sine squared of negative x over the tangent squared of x equals cosine squared of x. Well, let's write out our left-hand side again. Sine squared of negative x all over the tangent squared of x equals, let's simplify this. Well, the sine of negative x, it's an odd function, right? So you would normally get negative of the sine of x, but if you square it, you'll get positive sine squared of x all over tangent squared of x. Now we can simplify that tangent, right? This would end up being sine squared of x all over 1 all over sine squared of x over the cosine squared of x, right? Which, when we divide fractions, you're just going to invert and multiply. This would give you sine squared of x all over 1 times the cosine squared of x over the sine squared of x. Well, your sine squareds cancel out. You literally just have the cosine squared of x. So we've just verified the identity, therefore you can say the sine squared of negative x over the tangent squared of x equals the cosine squared of x. I should have 3 more. Alright, let's see. We have the sine of the quantity of pi over 2 minus x minus 1 all over the cosine of x. Actually, that's wrong. 1 minus the cosine of negative x equals negative 1. Alright, so let's write out our left-hand side again. So this would be sine of the quantity of pi over 2 minus x minus 1 all over 1 minus the cosine of negative x equals, let's simplify the left-hand side here. So what is the sine of pi over 2 minus x? That's a cofunction identity, right? So this would just simply turn into the cosine of x minus 1 all over your denominator. Now, what's the cosine of negative x? It's an even function, so you would just get cosine of x. So this would be all over 1 minus the cosine of x. Now, these look very similar. In fact, in the denominator, we can factor out a negative 1. So you would get the cosine of x minus 1 all over negative 1 times the cosine of x minus 1. And what do you know? You can cancel out cosine of x minus 1 from each numerator and denominator. It just gives you negative 1. So therefore, the sine of pi over 2 minus x, all that minus 1, all over 1 minus the cosine of negative x equals negative 1. We can soundly say that now. Should have two more. Now, we have 1 plus the sine of x all over the cosine of x plus the cosine of x all over 1 plus the sine of x is equal to 2 secant of x. So we have to verify this identity. We have 1 plus the sine of x over the cosine of x plus the cosine of x over 1 plus sine of x equals 2 secant of x. Well, we definitely need to we're going to have to first write out our left-hand side again. So 1 plus sine of x all over the cosine of x, all that plus the cosine of x all over 1 plus the sine of x. Now, we want to get a common denominator, right? So you got to multiply both fractions by the respective other denominators. You would end up getting 1 plus sine of x, that quantity squared, plus the cosine squared of x. All that all over the cosine of x times the quantity of 1 plus the sine of x. So now we got the same common denominator, which would simplify into 1 plus 2 sine of x plus sine squared of x plus the cosine squared of x all over the cosine of x times the quantity of 1 plus the sine of x. Alright, let's pause for a hot minute here, because that numerator looks really bad with quadratics. But what's the sine squared of x plus the cosine squared of x? That's simply 1, right? So this will turn into 1 plus 2 times the sine of x plus 1 all over the cosine of x times 1 plus the sine of x. Well, the numerator would factor into, well, it would turn into 2 times the sine of x plus 2 all over the cosine of x times 1 plus the sine of x. I'm going to start writing over here because I'm running out of room. So this would factor into 2 times the quantity of 1 plus the sine of x all over the cosine of x times the quantity of 1 plus sine of x. And look at that. We have a 1 plus sine of x that'll cancel out of the numerator and the denominator. So what you're left with is simply 2 over the cosine of x, which is the same as 2 times the secant of x. So that one was a bit long, but we got it. So therefore, we can say that 1 plus the sine of x over the cosine of x plus the cosine of x over 1 plus the sine of x equals 2 secant of x. So there we go. There's our proof. And I got just one more. All right. So we're given the cosine of negative x all over 1 plus the sine of x is equal to the secant of x plus the tangent of x. So we have to verify that the cosine of negative x all over 1 plus sine of x equals the secant of x plus tangent of x. Well, let's go ahead and simplify the left-hand side. So let's write out the left-hand side first. So the cosine of negative x all over 1 plus the sine of x. Well, what's true about the numerator? Cosine's an even function, so the cosine of negative x would actually turn into the cosine of positive x all over 1 plus the sine of x. And you're looking at this, you're like, okay, that's great, but how am I supposed to get from here to here? Well, what you can do, much like if we're working with radicals or with complex numbers, you can rationalize the denominator or multiply the denominator by its conjugate. So the conjugate of 1 plus sine of x would be 1 minus the sine of x. So yeah, multiply the denominator by its conjugate. I'm going to continue over here so we don't run out of room. So this would turn into the cosine of x times the quantity of 1 minus the sine of x all over 1 minus the sine squared of x, which would turn into the cosine of x times 1 minus the sine of x all over the cosine squared of x. All right, so we notice here now that a cosine is going to factor out. So this would turn into 1 minus the sine of x all over the cosine of x. Well, what are you left with then? You would end up getting the secant of x minus the tangent of x, which actually I think that was supposed to read minus. So that's my bad. I miswrote the sign up here. That should be secant of x minus tangent of x. But anyway, yes, we verified the identity. Therefore, we can say that the cosine of negative x all over 1 plus the sine of x equals the secant of x minus the tangent of x. So there is that identity. So that's it for verifying trig identities. So next lesson we're going to take this and we're going to solve trigonometric equations. there's going to be 2 lessons on solving trigonometric equations. The next one's going to be general solutions of trigonometric equations. So I hope everyone has a great day. Take care.